Hello everyone, welcome to this video. I hope you're all doing great. Welcome to this next subtopic of algebra which we are doing, which is functional equations. All right, so this is another very important topic. Guys, we are bringing something very important for you. It will be your stepping stone towards your success journey. It will be where you'll start putting your efforts. We'll be guiding you towards where to put your efforts to. So stay tuned and wait for the live session, which is going to be held on 9th of August, 7 p.m. Please be tuned in. You'll be having a lot coming towards your way, which is often overlooked in many cases, which is very unfortunate. But this is a very interesting topic as well. All right. Um, and this will include a very interesting derivation or proof of an interesting functional equation, which I will show as we progress. In fact, the first one is related to that. F from R to R be a continuous function which satisfies this linear property. The moment I say linear, it is linear, yes. For all real x and y with f of 1 equal to -2, then f of root 2 equals what? So how do we solve this? So we will solve this. You see, we will use limits for this. Limits of sequences. All right. So yeah, let's see what that means. Now, for every real x and y, this is true. So that means if I use f of n, that is equal to f of 1 plus 1 plus till n times. So this is equal to n times f of 1. Right? This is true for an integer. If I use m by n, you can write it for m times f of 1 by n. And how can I write f of 1 by n? In fact, if you see n times 1 by n, this is f of 1. So you see n times f of 1 by n is equal to f of 1. So f of 1 by n is equal to 1 by n f of 1. So this can be written as m by n f of 1. So you see that if r is a rational number, that will imply f of r is equal to r times f of 1. Right? Now this is true for rational numbers. What can we say about r belongs to irrational numbers? What happens to r? I'll maybe use t. T belongs to irrational numbers. What can I do? It turns out that for every irrational number, there exists a sequence Rn of rational numbers such that Rn tends to t as n tends to infinity. And in fact, we can prove it mathematically. How do we prove it? If you take Rn to be, I know one possible sequence is Rn is box of nt divided by n, right? What is this box? This is greatest integer function. This is greatest integer function. So you see that this is equal to nt minus fractional part of nt divided by n. This is n minus fractional part of nt by n. And you see that fractional part is always a finite quantity. It is between 0 and 1, right? It is always between 0 and 1. So sorry, this is not n, this is t. T minus fractional part of nt by n. Now as n goes to infinity, this term will go to 0. That will imply Rn will go to t. So this is one possible, you know, what do I say? Iteration, one possible example of a rational this thing. There can be many other possible explanations. You can find it for yourself. All right. Now that will imply, what does this imply? What does this imply? And it is given that f is continuous. One of the properties of a continuous function is that f of Rn limit n tends to infinity is equal to, this is a bit related to calculus, but I hope you don't mind that, is equal to f limit, f of, so the limit can go inside n tends to infinity r. So that is equal to f of t, it becomes, all right? So that will imply for each Rn, since Rn belongs to rational numbers, I can write it as Rn into f of 1. So it will imply as n goes to infinity, f of t will also be equal to t times f of 1. For t belongs to irrational numbers. So therefore, f of x is equal to x into f of 1 for all x belongs to real numbers. This is what we proved. So it is a linear function. So, and we are given f of 1 to be minus 2. So what is f of x is equal to minus 2x. That will imply it is minus 2, 2. As simple as that. I hope it was clear. All right. That's this question about. Again, pause the video and try out this question. I think this is a very interesting and very easy question to solve. F of x plus 2 times f of 1 minus x is equal to x squared. And we want to find f of 3. Pause the video and try, and I hope you have done that. So if you replace x with 1 minus x, you'll get f of 1 minus x plus 2 times f of x is equal to 1 minus x whole square. Yeah. So to find f of x, I just need to eliminate f of 1 minus x. So I'll multiply 2 times this. So I'll get 4 here, I'll get 2 here, and I'll subtract these both. So I will get 3f of x is equal to 2 times 1 minus x square minus x square. So it is 2 times x square minus 2x plus 1 minus x square. So this is x square minus 4x plus 2. And this is 3f of x. So you'll get f of x to be equal to x square minus 4 by 3x square, 4 by 3x plus 2 by 3. This is 1 by 3. F of 3 is, I'll get a 3 minus 4 by 3 into 3, okay, plus 2 by 3. So it is 3 minus 4 plus 2 by 3. So minus 1 by 3, because this is minus 1 and 2 by 3. So it is minus 1 by 3. Very easy. Very, very simple question this was. Next, as our tradition goes, this is a multi-correct question. F from R to R satisfies f of x plus y is equal to f of x into f of y. Right? Now, for all real x and y, this is true. And suppose f is not identically 0, which of the following are correct? Okay. Obviously, pause the video and try it out. I hope my face is looking nicely. Oh my god, my face is not looking nice. Okay. So yeah, try it out. So, see, this is kind of related to the previous question. I'll show you how it is related to that. But you can directly find f of 0, right? If you put x equal to y equal to 0, then f of 0 is equal to f of 0 squared. And it is given that f is not identically 0. Maybe I cannot use this. We cannot prove f of 0 is not equal to 0. We don't know that. So since f is not identically 0, that implies there exists an x naught such that f of x naught is not equal to 0. So I'll take x equal to x naught and y equal to 0. That should work. So that means f of x naught is equal to f of x naught into f of 0. So these two can be cancelled out because this is non-zero and f of 0 is equal to 1. So yeah, that is there. We cannot directly tell from here. X equal to y equal to 0 won't work. All right, we have to use this. F is not identically equal to 0. Fine. Which of the following are correct? Okay, so this is correct. F of x is greater than 0 for all x. Is that true? So let's see. If I take simply f of x, it can be written as f of x by 2 plus x by 2. This is f of x by 2 squared according to the given thing. So isn't this obviously greater than or equal to 0 all the time? This is always greater than or equal to 0. Now, can I say it is equal to 0 for something? That can't be made sure of. Can I say it is equal to something? Equal to 0. Suppose it is equal to 0 for some value, right? Um, can f of a be 0? Say there exists a y naught such that f of y naught is equal to 0. That will imply f of x is equal to f of x plus, or rather x minus y naught plus y naught. This is equal to f of x minus y naught into f of y naught. Then this is equal to 0. This is equal to 0, and this should be true for all x. So this is not possible. This is not possible. Otherwise, identically 0. Right? So that's the problem with this being equal to 0. So it has to be strictly greater than 0. This will imply f of x is strictly greater than 0. And option B is true. What is option C? If f is continuous. So continuity is not given. You see that in this question? Continuity is not given. If f is continuous, then f of x is equal to a power x. So if you take logarithm, so you have x plus y is equal to f of x, f of y. I hope you all know the properties of logarithm. If you take log f of x plus y, you'll get that equal to log f of x plus log f of y. And if you take g to be some function which is log of f, right? This will imply as f is continuous, implies g is continuous, and that will imply from question 1 that g of x has to be equal to some k into x. K is a real number. For this, it is necessary that f is continuous, right? F continuity is not it has to be an assumption. It cannot be taken for granted. All right, and that will imply f of x is equal to, I don't know, some a power, uh, whatever this log is, log base e generally we take. All right, I should have written ln, but anyways, this is e power k whole power x, which is some a power x. It is always some a power x where a is positive, obviously. All right, so we cannot have, if f is non-continuous, that will imply it is possible. F is not continuous is a possibility. All right. So there is something called Hamel basis of R over Q and all that. So it is related to linear algebra, that thing. We don't require, but it is possible that F is non-continuous. It is if it is not given in the question, we cannot assume it. All right. Eye to eye contact. I'm telling you. Please remember this. So if F is non-continuous, then G is non-continuous, and that will imply, um, what do we imply? What is the question? What is the question saying? F is necessarily continuous. That is not true. This is not true. But if F is continuous, then this is possible. Because if F is continuous, G is continuous. All of that. All right. So there we go. That's the question. Multiple choice. Only A, B, C being correct. Okay. F from R to R satisfies f of x is equal to x for every real value of x, which of the following are correct. F is a bijection. Okay, what does a bijection mean? Bijection implies injection plus surjection, right? That's what bijection is. Injection means if f of x equal to f of y. Doesn't that imply f of x is equal to f of y, right? Because if a equal to b, f of a equal to f of b. I'm simply using this property. and this should be implying that x is equal to 1. So injectivity, yeah, injectivity is holding, no problem. Now let's say we take y from the codomain R and say x is equal to f of y. What is f of x? F of x is equal to f of y, which is y. F of x is equal to y. Doesn't that imply y belongs to the range of x? Range of f, sorry. Doesn't that imply that for all y belongs to R, y belongs to range? Doesn't that imply range is R? Range is R. So that will imply surjectivity. That's it. That means it is bijection. No problem. F coincides with its own inverse. Now, since it is a bijection, we can talk about inverse. So f of x, f of x is equal to x implies f inverse of f of x is equal to f inverse of x. That will imply f of x is equal to f inverse of x. Very interesting. Okay, so it is coinciding with its own inverse, obviously. This is also very obvious because f of f is congruent to identity. So it is kind of obvious. Yeah. Again, is f necessarily continuous? Can I show a counter example? Let us say f of x is equal to x for all values of x belongs to real minus two values a and b, right? A not equal to b, obviously. And at a it is equal to b, at b it is equal to a. Does this still satisfy f of x is equal to x? Implies, do we still have f of a is equal to f of b is equal to a, and f of b is equal to f of a is equal to b. So these two are still satisfied. This still implies f of x is equal to x for all values of x belongs to R. But it is not continuous. But f is not continuous. So this is possible. Counter example. All right. So option C is not necessarily true. If f is strictly increasing, then f of x is equal to x. Wow. F is strictly increasing. When does that happen? That means if x is greater than a, f of x is greater than f of a. What if x is equal to f of a? Right? F of a is greater than a. That will imply f of a, which is f of x, is greater than f of a. But that will imply a is greater than f of a. Not possible. What if the other way around is true? What if f of a is less than a? That means f of a, since it is a strictly increasing function, is less than f of a. That means a is less than f of a. Both together are not possible again. So this implies that I cannot take f of a to be greater than or of greater than a, and I cannot take this is also not true. This will imply that f of a is equal to a for all a. That means f is an identity function. So this is a very interesting question. I love this. So I hope you enjoyed doing this. All right. So we have done two multiple choice, multiple correct option question, and now we are back to the subjective type questions. Subjective, yeah, subjective type questions. So pause the video, try it out, and as usual, I'll leave the last question as homework. I'll do all the homework question at once. That should be fine, right? So let's see how that goes. Okay, I want to observe something first. If I have um, t is equal to s square, right? That means f of t is equal to f of s into f of s, which is f of s squared, which is positive. Whenever this is positive, this is positive. First of all, can I have f of 0 is equal to 0? Hmm? Uh, if f of x naught is equal to 0, then I think I can have f of x naught plus y, or rather is equal to f of y, and that will create problems. Or maybe it is a constant function, right? That means f of y is a constant function. For all values of y, I am getting the same thing. So that will be equal to 0 because f of x naught is 0. So I'm removing 0 as a possibility, right? I'm removing 0 as a possibility. Let's say f of 0 is f of x is not equal to 0, is not identically equal to 0, right? So with this basic information, f of t, I can have this, right? Now, what else can I do? What else can I do? What is that saying, by the way? If t is positive or non-negative, that will imply f of t will be strictly greater than 0, given f is not identically 0, right? Okay. Now, what else can I say? What else can I say? If this is so, then f of 1 will be equal to 1 and all that. I think you can figure that out. I think that's easy. Let's see something else. If this is true, then I can also have, if I have u minus v, what is f of u minus v? What is f of u minus v plus v? That is equal to f of u minus v plus f of v. So that will imply f of u minus v is equal to f of u minus f of v. And if u is greater than or equal to v, that will imply this is positive. This will imply f of u minus v. It implies f of u minus v is positive. This will imply f of u minus v is positive. This means this is positive. This implies that f of u is greater than or equal to f of v. Uh, that is interesting to observe. All right, these two things are something worth noticing. This means f is an increasing function, can I say? Yeah. So f is increasing function. Okay. If f is an increasing function, what else can I say? I think this is very much related to the previous question. All right. So let's see. Let's see what can we do. Justify your list is complete. Hmm. I am guessing f of x is either 0 or it is equal to x completely, identically equal to x. So it is an identity function. So with that in mind, how do we get to that? F is an increasing function. F is an increasing function. So what did we have here? If f is an strictly increasing, then f of x. I don't think we will use that at all. Acha, I cannot use continuity. So obviously, again, I can prove that for rational numbers, this is true. For r equal to rational, I cannot use continuity, so I cannot say f of Rn. If Rn goes to t, limit n goes to infinity is equal to f of t. I cannot say this because f is not assumed continuous. All right. So we don't assume that. So what can we do? If you look at it, maybe I can use squeeze theorem or sandwich theorem, these things. So I can find for t belongs to real number, for t belongs to real number, I can find an Rn and Sn such that Rn goes to t and so does Sn go to t. Right? So with squeeze theorem, I can do that. Yeah, both are rational, and Rn and Sn both are rational. All right. So that will imply f of Rn is less than, since f is an increasing function now, I can write this f of Rn is less than f of t is less than f of Sn. So that will imply Rn f of 1, right? That's what we get for rational. Rn f of 1 less than f of t less than Sn f of 1. Now I'll take limit n tends to infinity implies tf of 1 is less than or equal to f of t is less than. If you apply limit, the equality doesn't remain strict. It becomes t f of 1 again. So that will imply f of t is equal to t f of 1 by sandwich theorem, right? By sandwich theorem. Okay, brilliant. The moment you have this, so that means basically f of x is equal to some constant into x. You have to put this into the other equation. So f of xy is equal to f of x, f of y. So that means cxy is equal to cx into cy. So this is c square xy. This will imply that c is equal to c square. That will imply c is 0 or 1. If c is 0, so that will imply f of x is either 0 or x. This is the complete list which you can have for x. All right. So the moment you can prove it to be linear, you can get this. So that's all for today. This question, I'll leave it to you as homework. Is a brilliant question. Use some mind, and I'll do all the homework questions at once. So in one video, I think you'll find it very interesting. All right. So that's all for today. Take care. Tata. Bye bye. So guys, a quick announcement. If you're interested in this video, most probably you're interested in higher mathematics which is beyond the school syllabus, beyond even the JEE syllabus, right? So if you are such a person who enjoys higher level mathematics, we're bringing a course for you named Target Math. We know that there is full math mastery, but that covers the mathematics in general. But this batch will cover mathematics in a higher level. All right, if you are interested in that, this batch is for you. It will be starting from 21st of July, so hurry up. It's going to start soon. It will be taken by the great Chetan sir. I hope you all know him. Definitely you must be knowing him. Now, who is this batch for? This batch is for class 12 students. It's for droppers. It's for ISI aspirants mainly, CMI aspirants also mainly. Or if you are simply aspiring for JEE and if you want a stronger mathematics, because JEE mathematics may not be that uh, stimulating for a lot of students unless you're doing calculus or something. But this batch will dig deeper into all the topics which are required for mathematics. If you enjoy mathematics, this batch is going to help you. Now, what are the highlights of this batch? There will be more than 95 live sessions, 3 sessions a day, 3 p.m. to 4:30 p.m. again taken by Chetan sir. UGA plus UGB pattern practice tests. So because ISI and CMI require higher level mathematics, and their pattern is in general, that's how they test, and that's why it is so good. You are going to be practicing in their pattern. Assignments every day after the session, Telegram group for discussions after the class, monthly progress report. This as constant in every batch. Now, a free bonus of ISA UGB mastery batch, right? If you're preparing for this, you'll also require preparation for UGB. If you know what UGB is, it is a subjective paper, 8 questions, 2 hours. So that mastery, writing a subjective solution is going to take some practice, and this batch is going to teach you that worth 1,000 rupees you're going to get for free if you take this batch before 21st July. Now, if you want to avail this price, please use the coupon code given below, and you can avail it only for 13,000 rupees. And remember, it is 95 plus sessions covering all of mathematics in depth. So yes, this price is definitely worth it. So please go check it out. Link will be in the description. Please go check it out. That's it. Take care. Tata. Don't forget the coupon code. Continue with the video.